Yes, hi again. This is George Larakis, and today I would like to discuss about the unit circle. The unit circle, it's a very valuable tool that you will use in math. Also, what I'm going to show you in the unit circle, it will help you a lot. It will help you in order not to memorize stuff. So, as you can understand, the unit circle, it's a circle, as you can see here, that its radius is 1, and in the x-axis we measure the cos, and in the y-axis we measure the sine. So, you see, as we said, the unit circle, it has radius 1, that's why we call it a unit circle. Of course, here is the origin 0, this is 1, this is 1, and of course, here is the negative -1 and -1. And what this here is useful is for finding the cos and sine of different angles. So let's make it clear what do we mean by that. Let's say that you take this angle here A. So A intersects the circle in the point C. So from the C you bring the projection of this here into the cos axis, and that intersects at A, and you do the same in the sine axis, and that intersects the sine axis on B. So if you measure this thing here, so let's say OA, it's equal with the sine of the angle A. This is of course less than 1, and it seems like it's approximately 0.8, let's say, so of course it's positive. And then this thing here, this segment here, the OB, is the cos of A. Which is again in the positive, and it looks like it's approximately 0.4. So that's what we mean that we use the unit circle to measure cos and sine. And let's add one more line, which is this line here, the green line, which is parallel, of course, with the sine line, and this is the line where you measure the tangent of this angle A. So that means that how you do it, let's say this is the angle A, you extend it after the point C, and in this point here D, where intersects the green line, so we have that, let's say this point here, D, A, B, C, D, E, the ED is equal with the tangent of A. Now, how you can somehow prove this is from the fact that if you take these two triangles, let's say if you take the triangles, we can erase this here. If you take the two triangles, the OAC and the triangle OED, these triangles are similar. Why they are similar? Because they have this angle here A common, and of course this angle here and this here, they are of course equal with 90 degrees angle. So that means that since they have two angles equal, it means that the two triangles are similar. So, and from the now let's take the tangent of A. I mean, as we all know, the tangent is equal with the opposite. I mean, if you take a triangle, and of course here we take the triangle ODA. So the tangent of this angle here is the AD, which is the opposite, over the adjacent, which is the OA. And now, since we said that these two triangles, they are similar, that means that the OA over, the AC over OA can be written also as, sorry, that's AC, sorry. So the AC over OA can be written as ED. I mean, it's the same ratio, ED with AE, with OE. Okay, I mean, this ratio here is equal with this ratio because of the similarity of the two triangles that we have here. And now, since the OE is what? Is the radius of the circle. So that means that this here is equal with 1. So that means that you have ED over 1. So, which means that is ED. So that's how you prove that the extension of this line with the intersection of the green line, the tangent line, that gives you the tangent of the angle. Okay, and of course here you can see that let's say if you take an angle, I mean the bigger the angle here, the bigger the tangent, and of course here is the positive. I mean this way is the positive, and this way here is the negative. So that means that the more the bigger the angle, the bigger the tangent, and of course when you reach the point of 90 degrees, because this line here and this line here they are parallel, that means that the sine of 90 degrees is infinity. So okay, so now let's do something else. Okay, let's erase this and see why this here is very important for anyone that studies math, and plans to take calculus. I mean, you have to know this unit circle because it will help you again in order to be able to find stuff and not to memorize it. Okay, so now let's try to find the cos and sine of the most important angles. So of course the most important angles, let's say if you put in this table here, let's say here is the angle A, here is the cos, and here is the sine. So, and the most important angles, they are of course, I mean we can put it in radians or in degrees. Let's put it in degrees. So you have the 0 degrees, then you have the 30 degrees, then you have the 45 degrees, then you have the 60, and of course finally you have the 90. So let's go and find without knowing anything and without having to remember anything, and of course without using your calculator, because in some problems you cannot use your calculator. So let's start. So you see here that angle 0, okay, since we start measuring from this axis here, I mean, as we said, this was the angle A, so that means, you go like this. So for angle 0, which is exactly here, you have that the cos of 0 is what? The cos of 0, I mean, how we said we find it, you bring the projection of this point into the cosine. So here the projection, if you bring the projection of this point to this point, to the cos axis, it's of course the same point. So if you measure it, it's what? It's equal with 1. And of course, if you bring the projection to the sine axis, it goes here, which is of course the 0 for the sine. So that means that the sine of 0 degrees is 0. And let's go and finish with the 90 because that's also very similar. So 90 degrees is of course this here. So if you go and you bring the projection of from here to the cos axis, it intersects at exactly this point here, which is 0. And if you bring the projection, of course, from this point to the sine axis, of course, it's the point itself. And just to make sure what is projection, it's the perpendicular. I mean, from this point, the projection to the cos axis is the perpendicular. That's why this angle here is a right angle. So that means that the sine of 90 degrees is 1, since if you bring the projection from this point to the sine axis, of course, it will give you, like this point here, the same point, which is 1, because as we said, always you measure this distance here. So the sine of 90 is 1. And now, let's go to find the next angle, which is the 30-degree angle. Okay, so as you see here, we have the triangle ODA, okay, which is exactly this triangle here, ODA. And let's say that this angle here is 30 degrees, because I want to find what's the cos and sine of 30 degrees. So what I do, I bring the from this angle here, which of course is 90 degrees, I bring the segment which intersects the OD in the middle. So that means that this point here, the P is the median of OD. And now from this point here, I bring the parallel. So this line here, the BC, is parallel with the DA. So now if I see, again, these two triangles, the ODA and the OBC, let's write it here, OAD and the OCB, they're what? They are similar again. Why? Because they have this here common, the O, which is 30 degrees, and then they have this equal with this. Why? Because both these are parallel to the line OA. So that means that this angle is equal with this angle, and of course they are 90 degrees, because this angle here, it's this angle, so it's 90 degrees. So that means that these two triangles, they are similar. So what does it mean? It means that since the ratio, let's erase a little bit here. So we have that this ratio here of OB over BD it has to be equal with the ratio of OC over CA. And of course, since this ratio here, it's equal with 1, because we said that B is the middle of OD, so that means that this here it's equal with this here, so that means that OB over BD is equal with 1. So that means that OC is equal with CA. So that means that this triangle here, the OBA, it's what? It's an isosceles triangle. Why it's an isosceles? Because this point here, this line here, the OC, it's a height and also intersects at the middle of the OA. So it means that this triangle here, it has to be an isosceles triangle, because this is the only case that this can happen. Like this, to be at the same time a height and to intersect this in the middle of the line OA. So, okay, so now from that what we get that since this triangle here, the OBA, is an isosceles, so that means that if this is story, this is story too. Okay, and okay, and this is story 2. So that means that this here is 60, and of course we know that this is 62 because, you know, I mean, this triangle here is a right triangle and this was story. The triangle ODA was a right triangle and this is story, so that means that this is 60. So excuse me, so that means that also this triangle here is isosceles. The BDA, actually this is more than isosceles, this is equilateral triangle, because, you know, if all the sides are 60, all the angles are 60, because if these two are 60, these and these are 60, this is 60, so that means that this is equilateral triangle, so that means that all the sides are equal, so that means that this is equal with this is equal with this. I mean, why I'm doing all this? Because I want to prove you that you don't actually have to remember anything when you're dealing with sine and cos. So now let's go and find the sine of 30. That's why, I mean, I'm doing all this to find the sine of 30 degrees angle. So the sine of 30, I mean, as we, by definition, if you don't know it already, the sine is the of a right triangle is the side which is across the angle over this line here, which is called the hypotenuse. So that means that for this case here, it will be the AD over OD. So we said that because this is equilateral triangle, we have that AD is equal with BD, and of course it's equal with BA, and of course BA is also equal with OB, because the BOA is also it's isosceles triangle. So OB. So what does it mean? It means that the OD it's equal with what? It's equal with it's equal with OB plus BD. So it since all of them they are equal, so that means that it's equal with 2. I mean, since this and this are equal, and the OD it's this plus this, so this plus this, and since all of them they are equal, we have that it will make, let's say, 2BD or 2AD. So that means that this here it should be AD over over OD, which we said that it's 2 AD. So this with this cancel, and we have that what we wanted, that the sine of 30 degrees is 1/2. So now that's it. You don't have to, you see, you don't have to remember anything. Now, let's erase also this triangle here. So the sine, I mean, we started from the sine, doesn't matter, the sine of 30 is 1/2. Now, you know, you want to find the cos. So we know that the cos, let's say, I mean, this here is 30, okay? So we know that the cos is this here, so it's OA. So, but what we have that the OA, when you have this here, it's a right triangle, and that means that you can apply the Pythagorean theorem, which what it says that the sum of the two perpendicular segments, so OA square plus AD square has to be equal with a hypotenuse square, but because this is a unit circle, the hypotenuse is the radius, and it's equal with 1, so it's 1 square, which is 1. So that's it. And now because we know that, excuse me, that the AD, of course, is equal with OB, is equal with the sine of 30, so that's 1/2. So you just go here and you solve this equation here. So we said that AD is 1/2, so 1/2 square, so that's equal with 1. And if you continue here, you have that OA square is equal with 1, and you bring this to the right hand side of the equation, so that should be 1/4, of course, with minus. So this will be, if you put everything under the same denominator, that should be 4/4 minus 1, so that should be 3/4. And so we have that the square, that the OA square is equal with 3/4, so that means that if you take now the square root in both sides, so that means that OA is equal with square root of 3. You can break this root here, and of course the square root of 4 is 2. So that's the cos of 30 degrees. So it's square root of 3 over 2, okay? So you see how beautiful we find it. And let's find one more thing, which is relatively easy. Again, I mean, let's now say that this angle here is 45 degrees. And let's make it, you know, the same triangle. I mean, it will not be exactly the same, but just because it will be easier for you to follow. So let's make this triangle here the OAD, but assuming that this here is 45 degrees. So let's make it here. So let's say this is 45. So again, this will be the O, this will be the A, and this will be the C. Okay, OAC. And of course, again, this here, it's the radius, the OC, so that's again 1. So let's go to find what's the cos and sine of 45 degrees. So you see this triangle here, I mean, since this here is 90, and this is 45, so that means that also this here is 45. So that means that what? It means that this is isosceles triangle. Okay, that means that OA is equal with AC. And now if you apply again the Pythagorean theorem here, what you have that OA square plus AC square will give you the hypotenuse square, which is 1 square. So 1. And of course, because these two are the same, you have that, let's say, 2 times A times OA square is equal with 1. So from that you get that OA square is equal with 1 over 2. So then if you take the square root in both sides, you have that OA is equal with 1 over it's equal with the square root of 1 over 2, and because usually we don't like square roots in the denominator, we want to rationalize this, so that means that there is no square in the, there is no square root in the denominator. So what we can do, we can multiply both of numerator and denominator by square root of 2, and that will give you that, let's write here, that OA is equal with, if you multiply both numerator and denominator by square root of 2, that will give you square root of 2, and of course here you have square root of 2 times square root of 2, so you have square root of 2 squared, so this cancels with this, and that gives you that OA is equal with square root of 2 over 2. Okay, so now that I have this, I can continue and find the cosine sine of square root of 45. Now the cos of 45, it's, as we said again, it's the adjacent, so it's OA over the hypotenuse, which is 1. So I have that OA is equal with square root of 2 over 2. So that means it's square root of 2 over 2 over 1. So that's equal with square root of 2 over 2. So that goes here. And of course with exactly the same logic, just saying that sine of 45 is the opposite over the hypotenuse. Again, it's the same exactly thing, so you will find that also the sine of 45 is square root of 2 over 2. So now I want to show you something which it has to do with the use of the unit circle in order to find the cos and sine of angles with respect to some other angles. So, let's say we have this angle here. Let's call it again A. So, the cos of this angle, it's this here, and the sine of this angle is this here. So now let's go and draw an angle A here. This is A. So now let's find also the cos and sine of this angle here. So if you bring again the perpendicular from this point to this point, we have that this here it's now the cos of this angle here, and this here so this here is the sine of this angle here. I mean, if you see what happens is you see that this here, which is the cos of the angle A, if you see it, this is almost the same length as this here, which is what? Which is the sine of this angle here. So, and so what, let me tell you exactly what I mean. If you see, you have that, let's say this here, which is the cos of A, which is this segment here from here to here, it's equal with this here, which is what? This is the sine of this angle here. So how much is this angle here? This angle here, since we said that this is A, this angle here is 90 minus A. So, and now if you take the this here from here to here, which is what? This is the sine of this angle. The sine of angle A is, if you bring the projection from here to here, is this segment here. So this here, the sine of A, is equal with what? Let me tell you, it's equal with what? It's equal with, this from here to here, it's the same with this here, which is what? What is this here? This is the cos of this angle here, because the projection from this point to the cos axis comes here. So this small segment here is the cos of this angle here, like this angle here, which is what again is 90 minus A. So what have we? So here we see that angles that they sum up to 90 degrees, they interchange cos and sine. So that means that since 60 and 30 they sum up to 90 degrees, so that means that they have to interchange cos and sine. So that means that the cos of 60 will be the sine of 30, so that should be 1/2, and the sine of 60 will be the cos of 30, which it will be square root of 3/2. Yep. And of course, even without, let's say we didn't know this, the cos and sine of 90 degrees, you can get it using this here, because 0 and 90, they sum up to 90, so that means that they interchange cos and sine. So that means that this goes here and this goes here. So that's the most important thing of the unit circle. What's the most important thing? Is that if you are able to see these things on the unit circle, you don't have to remember anything. So you can find the relations between angles, and you don't have to remember formulas like what's the relationship between angles that their sum is 90 degrees or their sum is 180 or any other combination. Let me, for example, and you can always relate these angles to the let's say to the basic angles or the reference angles, which are always in the first quadrant. I mean, this here it's the first quadrant, the second, the third, and this is the fourth quadrant. So you can always refer any angle to the cos and sine of any angle to the two angles in the first quadrant. So let's say, for example, you want to find what's the cos of this angle here. So like this angle here. So you want to find the cos. So what do? And you want to express it in terms of the trigonometric numbers that are in this quadrant here, the first quadrant. So that means that there are angles between 0 and 90 degrees. So I mean, what you can see here is what is the cos. The cos, it will be this segment here, from this point to this point. So if you see here that if you do this angle here, which this and this are equal, and you bring this, you have that this segment and this segment, they are equal, but the one is positive because from here to here is positive and from here to here is negative. So the one is positive and the other is negative. But as segments, you know, this and this, they are equal. So, and the one, it's the cos of this angle, and the other is the cos of this angle. So that means that the cos of this angle here, I call this, is equal with the negative cos of this here. And of course, these two angles, if you see, like this angle and this angle here, like this small angle here, are what? They're angles that they sum up to 180 degrees. So that means that the, again, angles that they sum up to 180 degrees, they have opposite cosines. And let's say also you have to find, let's say you want to find the sine of this angle here. What you have to do is you have to bring the projection, so from this point here to the sine axis, so it intersects here. So that means that the sine of this angle here is this segment here. And of course, if you can see, if you bring the perpendicular line from this point to here to the sine axis, it will come approximately to the same point. Actually, you know, if the circle was perfect, it would come in the exact point. So it means that these two angles, they have what? They have the same sign. So actually, angles that they have angles that their sum is equal with 180 degrees. They have, as we see, opposite cosines and the same sine. I mean, you know, let's say also, you know, you have this and this angle. So I mean, let's say you have this angle here now, this, let's say this here. And you want to find the cos and the sine of this angle. So you see that, I mean, in order to find the cos and the sine of this, what we do is you bring from this point the perpendicular to the cos axis. And so if you see, like, if you bring now an angle like this, which is, you know, this angle here is equal with this angle here, you see that the cos of this angle and of this angle, it's what? It's the same, because, you know, the cos of the one is this and the cos of the other is also this. And if you want to find the sines, what do? So you see that the sine of all these, it's, you know, it's this segment here, from here to here, and the cos of this here, it's, this segment here. So you see that they're equal, just the one is on the positive sign and the other is in the negative, so that means that the signs are opposite. So that means that angles that sum up to 360 degrees, they have the same cos and opposite signs. So this way you can play around the unit circle and like measuring these segments, and of course the more accurate is, the more perfect is your unit circle, the easiest is to see these relations, and this way you don't have again to remember all these like rules that relate angles among themselves. I mean, it's like another. I mean, we have cos sine and of course tangent of A. I mean, of course the tangent is. The tangent, if you have the right triangle, it's the opposite over the adjacent. And let's say you have this triangle here. Just let's say it's right here. This is the opposite. This is the adjacent. And this is the angle that we have to find the tangent. So it's opposite over adjacent. And of course, you can also write it as sine of A over cos of A. And with this, I can just give you few problems to do, and I will give you the solutions. I will show you the solutions on the next lesson. So let's find what's the cos of 150 degrees, what's the sine of 120 degrees, what's the cos of 315, what's the tangent of 210, and finally what's the tangent of 270. And I will give you the answers, but I want you to try to find it yourself. So this is for the first, this is for the second, this is for the third, this one is 1 over square root of 3, and finally this here is minus infinity. I mean, and I want you to find these questions using only the cos and sine of the angles that I just showed you: 0, 30, 60. 0, 30, 45, 60, and 90. So, with just with this to find these questions here. Thank you for taking the time to view this video, and I hope you find it useful, and bye for now.